we have drawn a random sample of 100. So if we have 100 people in each sample, then we can draw 10 samples. So let's say, look at line number 4. Let's say we have drawn 10 samples from our population and we calculated the average of age from all 10 samples. So now we have, 10 samples, we have calculated the age of, mean of age from each sample. So now we have a distribution of, not raw score, a distribution of means calculated for each sample. Are you guys with me? See, before, if you look at the examples we had so far, we had a list of raw scores. Now, like, remember the question I think we worked on was the data of in which country is more dispersed than the other one. If you look at those were raw scores, there was no mean calculated. Here, we are calculating mean for each sample. Then we are saving those means, and by saving those, we are coming up with this kind of table. If you look at further down, that's the kind of table we are coming up with. That's what they are talking about. So we have 10 means from 10 samples. Now, the point is, you know that this is very logical. If you are drawing 10 samples from your, even though the population is same, because the people in each sample, they vary, that's why, even though you have the average age from each sample, that will vary from sample to sample, right? So they are saying that even though it varies, but we can still keep those, we can put them in a distribution like raw scores. And that distribution, the picture I showed you guys, that distribution like these, mean age from each sample. This kind of distribution is called sampling distribution of means, because each line, each one you look at, they are talking about the average age. So that's why it's called the sampling distribution of means. Now, important point is the sampling distribution of means, this is a theoretical distribution. We never actually create or construct this kind of distribution. So statisticians, the fact is, normally when we conduct a study on a large population, we don't have access to that population. Think about it. If you are going to study a population of 1,000 people, it's not really possible to study every person in the whole population. We don't have access. So statisticians, they have identified something called central limit theorem. What is a central limit theorem? This is what it means. Simply put, it states that as long as you have a reasonably large sample size, for example, in each sample you can have about 30 people. You don't need to have 100, you can have 30. As long as you have a reasonably large sample size, sampling distribution of means, meaning these means distribution we have for 10 samples, they will fall under the normal curve. Another important thing, if you look at that same paragraph further down, the last sentence, even if you have less than 30 cases in your sample, sampling distribution of means will probably, oh my God, there is a typo, will be near normal if you have at least 10 cases in your sample. So you don't even need 30 people. Even if you have 10 cases, 10 people in each sample, and then you calculate the sample means from each sample, then this distribution of sample means, it will still fall under the normal curve. So this is what we have. According to the central limit theorem, as the size of the sample, and for sample size, we use this lowercase n, and we use this uppercase N for population. So as the sample size n increases, the shape of the sampling distribution of the means, like these, mean of age, this shape becomes almost like a normal curve.